Father's Day is just around the corner. If you're anything like me, you want to give your dad the best gift possible. Ridge has redefined the wallet and the, wait for it, key holder game with their slim, stylish, and durable products. And the best part, they're having one of their biggest sales of the year just in time for Father's Day. But before we get into that, let me tell you about why their products are so awesome. First, let's talk about the Ridge wallet. It can hold up to 12 cards. I have 3 in here. I don't have 12 cards, but if you do, it'll hold them. Also can store cash here on the back nice and easily, and it remains super slim. They've also got 30 colors and styles. This is burnt titanium. I've got another one here, which is carbon fiber. Plus they've got RFID blocking, so they keep your information safe from digital pickpockets. And if you're always misplacing your wallet, I definitely am known to do that. Well, you can even get an AirTag attachment so you'll never lose it again. Also, the key case is fantastic. This carbon fiber matches the wallet. It's sort of like a Swiss Army knife for keys. You put your keys in here once. These are my office keys, and it's super easy to use. No more jangling about in the pocket. If you buy both of these things together, by the way, you get 30% off. They've got over 3 million customers, 50,000 5-star reviews, and Ridge are so confident that you'll love their products, they offer a 99-day trial period and a lifetime warranty. Go to ridge.com/sideprojects to save up to 40% off your Ridge purchases through June 15th. Again, ridge.com/sideprojects. Thank you to Ridge for sponsoring. And now today's video. As we march on into the 21st century, technologies only dreamed of in science fiction are becoming more and more commonplace, but perhaps the most astonishing of technologies has come in the quest to explore the final frontier of space. NASA has captured headlines and our imaginations in recent years with missions like the Mars rover and the James Webb Telescope, but just when you thought you'd heard it all, think again. From the surface of the moon to the oceans of Jupiter and the moons of Saturn, NASA has been extending the borders of human endeavors, breaking barriers of technology in fields from artificial intelligence to manufacturing. The new space race has put more power and possibility at our fingertips than ever before. Today we'll take a look at projects NASA is funding that are sure to blow your mind. The Dragonfly. In the vein of historic missions to the moon at the height of the Cold War's space race, NASA is looking to explore more lunar surfaces, but this time they're extending their reach to moons of our neighboring planets. The Dragonfly mission will explore Saturn's moon Titan. Using a nuclear-powered quadcopter to fly around the moon's surface, NASA hopes to collect data on its complex chemistry and potential for life. Scientists hold out hope for finding signs of life since, based on the data they currently have of Titan, it's very similar to the Earth in its younger years. The spacecraft will explore diverse territories on Titan's surface, from desert dunes similar to geography in southern Africa to the once water-covered floors of impact craters covering ground in leapfrog flight stretching up to 5 miles or 8 kilometers long. Though this mission may seem out of this world, the idea has precedence in Ingenuity, the helicopter that successfully landed and took off from the surface of Mars. However, unlike Ingenuity, Dragonfly will be the first time NASA flies a multi-rotor craft on another planet. Flying similar to a drone, the Dragonfly craft will take advantage of the thick atmosphere on Titan, 4 times thicker than Earth's to be exact. The proposed timeframe is for the mission to launch in 2026 and reach Titan by 2034. Space elevators could turn an extremely risky and expensive venture, launching astronauts into space in rockets, and turn it into a simple matter of transit. Though it sounds like science fiction and has been the object of many sci-fi writers' dreams, NASA has invested in making space elevators a reality, possibly in our lifetime. In 2009, NASA held a competition designed to spur scientific research into this topic. In the end, Laser Motive, a Seattle-based company, won $900,000 for developing a laser-powered robot that could climb 900 meters of cable suspended from a helicopter in under 4 minutes. A space elevator, when broken down, is essentially a cable tethered to the ground extending up into space where it would be connected to a satellite. The centrifugal force of the Earth's rotation would keep the cable stretched taut. Imagine you attached a dumbbell to a rope and spun it around. As simple as this sounds, there are a couple of significant obstacles to overcome first. The material of the cable would need to be about 50 times stronger than steel. So far, no one has come across such a material that can be produced quickly and cheaply. The other big obstacle is perception. When Arthur C. Clarke, famed author of a novel about the building of the first space elevator, was asked when his dream might become a reality, he replied, probably about 50 years after everyone stops laughing. That was back in the 90s, and since then, not much has changed. Despite NASA's funding of the competition, the amount awarded pales in comparison to the hundreds of billions being spent trying to reach Mars. The rockets launched in those missions use around 90% of their mass just carrying the fuel that they'll burn to leave Earth. But, well, it's the space elevators that still have the bad image. The Mars Ice Mapper project is a proposed NASA mission in partnership with the Japanese, Canadian, and Italian space agencies that aims to provide new insights into the history and distribution of ice on Mars. The project would use radar instruments to map the subsurface of the planet's south pole, where a thick layer of ice is believed to exist. From a scientific standpoint, the Mars Ice Mapper project could help answer some of the biggest questions about Mars, such as whether the planet ever had a habitable environment and whether there's still water ice present today. This information could help scientists better understand the processes that shape planetary bodies in our solar system and the potential for finding life beyond Earth. From a societal perspective, the Mars Ice Mapper project could have important implications for future human missions to Mars. Understanding the location and distribution of ice could be critical for mapping landing locations and establishing a sustainable human presence on the planet. Ice can be converted into drinking water, breathable air, and rocket fuel, all of which are essential for long-term human habitation. The Mars Ice Mapper project has the potential to revolutionize our understanding of Mars and pave the way for future exploration and discovery. By unlocking the secrets of Mars's icy past, we may find the keys to unlocking our own future as a spacefaring civilization. The Lunar Surface Innovation Initiative, or LSII, is a program whose aim is to develop innovative technologies that can support sustainable exploration of the Moon. The LSII program focuses on 5 key technological areas: using resources on the Moon to support human exploration and habitation, prevent damage from the fine lunar dust to infrastructure and people, using renewable and easily stored sources of energy, designing robotic systems to operate on the Moon independently, and establishing high-bandwidth data links between humans and robots. Similar to the methods used in the Mars Ice Mapper mission, these goals can be achieved by mining water and ice to process into drinking water and rocket fuel. Regolith, materials from the bedrock of the Moon, could also be used for the construction and radiation shielding. The Lunar Surface Innovation Initiative also aims to develop advanced mobility technologies such as rovers and other surface vehicles to enable more extensive exploration. AI and machine learning are helping NASA analyze vast amounts of data and perform complex calculations quickly and accurately, making it possible to discover new insights into our universe and make more informed decisions about space missions. NASA is working on several exciting projects on this front. For starters, the Mars 2020 mission, which launched the Perseverance rover to Mars, used AI to help the rover navigate the planet's rugged terrain. Machine learning is also being used to analyze data collected by the rover's cameras and instruments, helping scientists to better understand the Martian environment and search for signs of past microbial life. The James Webb and Kepler Space Telescopes use AI models to analyze data from them. With these algorithms, scientists have used the telescopes to discover thousands of exoplanets orbiting other stars, detect and classify galaxies in deep space, and map the earliest structures of the universe. Solar sail technology harnesses radiation pressure from sunlight to propel spacecraft. Large, lightweight mirrors are used to reflect sunlight, generating a small but constant thrust. The technology behind solar sails is based on the principle of momentum exchange. Photons of light carry a tiny amount of momentum. When these photons reflect off the large mirrors of a solar sail, they transfer some of the momentum to the sail, providing a small amount of thrust. While this may seem insignificant, over time, the small but constant force generated by a solar sail can propel a spacecraft at very high speeds. Solar sails have the potential to revolutionize space travel. Unlike traditional rocket engines, solar sails do not require any fuel. This could make them an effective and much more efficient way to explore the outer reaches of our solar system. The Europa Clipper mission is a flagship part of NASA's Outer Planets program. The mission's primary aim is to study Jupiter's moon Europa, which is believed to have a subsurface ocean of liquid water. For that reason, it's considered to be among the most promising places in our solar system to look for life beyond Earth. The Europa Clipper spacecraft is equipped with a suite of scientific instruments that will allow it to map the surface of Europa, analyze its composition, and study its geology and ocean. The spacecraft will perform multiple flybys of this Jovian moon, getting as close as 16 miles or 25 kilometers to its surface. The spacecraft will also study the moon's surface and search for evidence of geysers or plumes, which could provide insight into the ocean below. The mission also aims to investigate the potential for a landing site for future robotic missions. By studying Europa's potential for habitability, researchers hope to better understand the conditions necessary for life to exist elsewhere in the universe. The cumbersome part of space construction is getting the materials there in the first place. But what if one launch containing a fraction of the materials normally needed could provide all of the tools and parts needed for dozens of projects? Enter in-space manufacturing. NASA is at the forefront of these developments, funding and supporting several projects that focus on developing and testing in-space manufacturing. These projects take advantage of 3D printing technology to build items such as satellites, habitats, and even entire spacecraft. NASA's Made in Space project is developing the Archinaut system, which is set to launch after 2024. It's slated to construct 2 beams, one 20 feet, 6 meters long, and the other 33 feet or 10 meters long, to provide a structure for an array of solar panels. This technology could enable the future construction of large telescopes and even habitats on the Moon or Mars. Laser beams can transmit much more data per second than traditional radio waves, allowing for faster and more efficient transfers. Additionally, laser beams are much more focused than radio waves, so they can be targeted more accurately and are less susceptible to interference. The technology allows for the real-time transfer of high-definition video and images from deep space, which can help scientists to study distant planets, asteroids, and other celestial bodies. It can also improve the efficiency and reliability of communication between spacecraft and ground stations, which is crucial for missions that involve timely communication over long distances. NASA scientists are exploring the use of fluids in shaping mirrors or lenses. This novel approach could lead to more powerful telescopes. Traditional telescope mirrors are often made from a special type of glass and are vulnerable to impacts by micrometeoroids and shaking during launch. The size of the launch rocket determines the diameter of a mirror, which affects the resolution capability of a telescope. However, the fluidic concept would eliminate these limitations. As impressive as the James Webb Telescope is, it could pale in comparison to a potential fluid telescope when it's not held back by the same restrictions. An umbrella-shaped satellite dish that is launched along with a tank of mirror liquids such as gallium alloys and ionic liquids would then be injected into the frame. The zero-gravity environment of space would allow the droplets to stick together through surface tension, creating an incredibly smooth mirror without the need for mechanical processes like grinding and polishing. This would eliminate the need to fold a delicate mirror into a rocket and reduce the complexity and the cost of the launch process.